Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So I am back with the new video on DP. So this will be my DP video 11. Okay, so you see we will start with a new topic for today, DP on strings, and the topics on this, the problems on this topic can go really hard. Okay, so let's see. We will start with a very simpler question for today. Okay, and we will extend our concepts of take not take DP only to strings, and also have some more intuition about how to solve DP on strings problem. So definitely this take not take is one of the intuitions. So we will solve two Leetcode problems today. One is the very common long question, is that longest common subsequence. Okay, so we will solve this problem, and after that we will also solve know how to solve a very related problem, which is nothing but longest palindromic subsequence. Okay, so stay till the end of the video. Definitely you will get to understand in detail and in depth of how to think on such problems, how to think like DP, and how will you understand exactly why you need to apply DP, when to optimize, how to optimize, and stuffs like that. And I will definitely hope that you have already watched my previous videos. If not, you already know the concepts of things like recursion, memoization, and then tabulation. Memoization is nothing but a recursive form of DP. It is also known as recursive DP, and this is nothing but an iterative DP. Okay, so I hope you know these concepts. Either you know these concepts, then it's okay. Otherwise, you can just watch my first 2 to 3 videos. I hope you can easily understand that, and then you can also start with this DP on strings question. Okay, so let's try to understand the problem statements. What do they say? Okay, so what is this question? This question says you need to find longest common subsequence between two texts. Okay, so you are given two strings, text1 and text2, and return the length of their longest common subsequence. If there is no common subsequence, return 0. So if you can understand that, what is the meaning of this subsequence of a string? Subsequence is nothing but a new string which is generated from the original string with some characters deleted, can be none also, without changing the relative order. So for example, if you consider this string A, B, C, D, E, A, C, E is one possible subsequence. Even A, B is a possible subsequence. Even A, D is a possible subsequence. A, D, E, A, B, C, E, all these are possible subsequences of this string. Okay, they may not be together. For substrings, for the definition of substring, they always need to be together, like BC, ABC, ABCD, or BCD. These are substrings, but subsequences may or may not be together. Okay, so we need to find a common subsequences of two string. Okay, so and we need to find the length of the largest one. So if you have two strings, if you see ABCDE and ACE. Okay, so if you have one string which is nothing but ABCDE and ACE, so you see A and A is a common, C and C is common, E and E is common. So ACE is a largest subsequence in these two strings, and it is of length 3. So you return 3 here. Okay, so your answer will be 3 here. Okay, so I hope you do get it. And if you see what will be the answer of this, if I try to tell you A, D, C, E. So in subsequence you need to know that order always matter, because if you try to think it something like that, A goes with A, D goes with D, C goes with C, E goes with E, and your subsequence, common subsequence is A, D, C, E, or is of length 4, then you are absolutely wrong here, because you see order does matter. What is the subsequence which, if you are taking this order, what is the subsequence of this? You see A, C, D, E is the subsequence of this. Now A, if you try to call this subsequence of the next string, A, D, C is the thing. So they are not equal, right? You need to find the things which are equal. Since a path is crossing between them, they will prove to be not equal. So what can be the possible answer here? Here also the answer will be A, C, E. You can say it A, C, E again and tell that the answer is 3. Or you can do another thing. Instead of ACE, you can also tell your answer can be ADE. Okay, you see still paths are not crossing. ADE is a possible subsequence of both of these strings. So A, D, E can also be the thing, and it is of length 3. So I hope you do understand what the question wants to say is. It just wants to find the length of the longest subsequence. Now how will we approach this problem? Now it's very simple, I guess. I think you can easily think this on your own. If you have understood all my previous videos, you should be able to do this on your own. Okay, so what can you do? You first of all, you look at the constraint. It is 1000 constraint. So you can have I mean, you can iterate twice. You can have a double for loop. Okay, so how will you approach this? The first thing which comes to mind is that you can have two pointers. Okay, I1, let's say I1 is pointing to this string and I2 is pointing to the first element of the next string. Initially both are pointing at A. So if you see if they are common, you can definitely take them into your answer. You can definitely take them into your answer and move to the next string, move to the next element. Now you will get I2, I1 here, and I2 has also moved. Now you see they are not equal. One is B, one is D. Then you have two choices. So you see, you remember, do you remember take not take DP, right? You either choose to take not take. Instead of take not take, what we can do, we can move not, we can do move one or move two. What do I mean by this? When two elements, when two pointers are pointing to two indices, two elements, and they are not equal, what you can do, you can choose to move the first one or you can choose to move the second one, and I mean you can just keep one constant and choose the next one. Okay, so you can do this easily, I hope. And let's say you have chosen to move the I1 at the first, and then you are pointing to now C, and still you are pointing to D, and then what you can do, you can again choose to move either of them. If you move the down pointer, you will go to C and you will see that you have got a common element. If you choose to move the up pointer, you will go to D and again you will see that you will have a common element DD. Okay, so in this way you can proceed. In this way you can write a recursive solution. Okay, so first we will understand how to write a recursive solution. As I will write the solution, things will become more clear to you and very easy for you, I guess. Okay, so I guess this will be not at all difficult for you. You need to find a subsequent length of the subsequence only, which is common among them. Okay, so I will first write with the recursive solution. Okay, then I will try to write the recursive DP approach, and I will write the recursive DP approach, and then I will write the iterative DP approach, and we will see how time complexity, space complexity optimizes over all these methods. Okay, so as I will find a recursive solution, so as I know, as I have already told you, what will be the states of the DP? It will be two indices and they will be initially starting at 0. Okay, so you can have two indices and they will definitely be starting at 0. So you can write a function recursion. Okay, so you can have, let's say, a function recursion, and this will take text 1 as the first element, text 2, and it will have two pointers 0 and 0. Both are initialized at 0 initially, right? Both are at 0. So I hope you do understand what I try to say is that these both are at initially 0, pointing to index 0. Okay, because they are both at pointing at the first element, and we will move them one by one. Okay, so this is also nothing but the brute force approach. You see, I'm not thinking much about optimization. I'm just trying to solve the problem. Okay, so that's what exactly is it is. So if you try to see, if you try to do something like string text 1. Okay, so remember it that you need to pass it by reference, and also string of text 2. Okay, so you pass both the strings and you have pointer 1 and pointer 2 pointing at the both of those strings. Okay, so you keep these two pointers at first, and you also have the total length of the string, because nowhere it is told that the length will be same. Definitely the both of the lengths of the string can be different, and yeah, so you need to have n1 and n2 defined clearly. So text2 dot size is also there. So you have these two. Okay, now what will the first thing while writing recursion you need to think is that how to write the base case of recursion. Okay, how to write the base case of recursion. So what will be the base case here? At the point where it will end. Okay, so let's say it has a length of 5. Okay, so let's say A, B, C, D, E has a length of 5 and the index numbers are 1, 2, 3, 4, and let's say it is 5. The pointer is now pointing at 1. So if this pointer ever reaches the last, okay, it ever reaches the last, it means that there is no further element of string to process, and you can just return 0 because there is no progress. I mean, you cannot compare nothing. I mean, there is nothing to compare with the next string. Okay, so either of these, this is I1 and this is I2, which is pointing at A. So either of this, if it reaches the end of the string, you can just call it to return 0. So what I will do is very simple. I will say that if my I1 becomes equal to N1, I hope you can understand, because this is the fifth, N is the length. Okay, so I am going to that particular index, or I2 becomes equal to N2. What you can do, you can simply return 0. Okay, you can simply return 0. I mean, you cannot process any further, you cannot get any common length. There is no length available. How will you get a common length? So I hope that's simple and clear. Now the first thing which can happen is that both of the elements can be equal to each other. Okay, so how will you represent that? You can easily say that if text1 of I1 is the correct index of text1, you go to that character, and for text2 also you do the same. If they both are equal, what should you do? If they both are equal, you can take both of them into your consideration. So I mean to say that your common subsequence has a length of 1, it should increase. I am finding the length of the common subsequence, right? So my length just got increased by 1 because I found one common element. So my length has got increased by 1. I can write 1 plus the remaining. Okay, so the remaining thing I can just call it by recursion. So text1, text2, and I will go to the next index, and I will also move to the next index. So I hope you easily understood what I am trying to say. It's simple. It's the thing that we got A common at first, so we incremented our length by 1, our answer which is returning, we incremented it by 1, and I am adding to the remaining element. Now my string has I mean I1 and I2 both have moved by 1. Okay, I1 and I2 both have moved by 1 element, and it wants to calculate the answer which is there further. Okay, so it will again call this function, and if they are not same, what to do? We come out of this if statement, and if they are not same, we can first order a move 1. Okay, so let's say I will tell the first pointer that you try to move and tell me what is the answer. So recursion of text1 again, text2 again, and also you can do something like I1 plus 1, because I am ordering the first pointer to move, the second pointer remains still. Again I will this is the one possibility which I am exploring, right? Again another possibility which I can choose to explore is that I can tell text1 and text2, both of them you go, and I1 remains same and I2 you increase. So I am telling move 2. Now whichever I am exploring all these possibilities, right? This will again call this recursion and explore this function and keep on going on. Okay, so I am going on exploring the other parts of the string. As I am doing so, when I will return, when I will backtrack, I will tell that whichever decision, making move 1 or move 2, whichever decision gave me the best answer, I am going to go with that. So whether move 1 gave me the best answer or move 2 gave me the best answer, the maximum among them I will choose to move. Okay, and I hope this will give you a correct answer. If you try to run it and check, this should give you accepted with the small test cases actually. So you see you got accepted, but if you try to submit, you will definitely get a TLE. Why? Because I have already explained you many times that it is a recursive solution, so it has 2 to the power n time complexity, and it will easily run out of time. So what you can do for after you have write the recursive solution, you can look for a recursive DP approach. Okay, so I hope in recursive DP there is nothing much to think actually. You already know that. So you just need to see the states of the DP, to what length it can go. You know that these are the extreme points till where your states I1 and I2 can reach. So you can just copy this. Okay, so you just copied this, and you see you can create a vector DP, vector of DP, and initially the whole DP table is empty. to signify the emptiness, you can initialize all the elements of the table with -1. I have already explained you these methods and how why exactly they work. Also, I have explained you. Okay, so you can just have it. I mean, it is not much difficult to understand. Also, intuitively, right? I am creating a table. I am just catching my elements. So since in the recursion tree, if you draw the recursion tree, you will get a lot of duplicate elements, and you want to get rid of those duplicate elements. So I am using a catch memory type of thing for this thing. Okay. So how will I use the catch? I can tell that if my table is empty. So if something like this happens, I1, I2, if it is not empty, okay, I mean it is not -1. Initially I initialized everything by -1 to tell that it is empty. But if it is not empty, do not calculate anything further. Do not calculate anything further. Just return dp I1, I2. Okay. And if you need to calculate, I mean if you need to calculate, then do remember to save the states. So this is nothing but I am just saving these states. So this thing, the final answer which I got, I definitely need to save them. I definitely need to save them into my DP table, so that next time when I come, I do not need to repeat this, and I can maybe return from this state itself. So here you also see that there is another return statement. So definitely you need to save this also. While just before returning, it's like you calculated some answers, and so that you don't forget those answers, you are saving into your DP table, and later when you already are repeating those questions, you are just returning the same answer instead of calculating every time. So I hope this makes things very clear, and it's very easy to understand also, I guess. Now if you try to submit it, you might get accepted, but not that much runtime complexity maybe. So you see, you do have something like what is the error? Okay, so you can easily understand that I have not passed this DP function here. Okay, and what you can do, instead of writing the whole thing again, you can just return DP here also. I guess that will be the same thing. Let me try to run initially with small test cases at first. Okay, so all of these things, I mean, I hope you can understand easily. That I forgot to pass the last argument of DP, so you just pass it and it should work just fine. So it's taking some time to run. Okay, you see we do have the accepted thing. If you try to submit it now, earlier we got quite a less number of test cases passed. Okay, so you see you did get accepted, but your runtime complexity is not that good. But you did get the accepted thing, right? And I mean in competitive programming or in the DSA tests also, it is very fine to just remove this. If you have all the accepted cases, you don't need to optimize it any further. But in interview they might ask you an iterative solution. Okay, so you must know an iterative approach also, because it looks cool and it's a short code, and I had already explained you how will you convert this recursion to iteration. Okay, so I will now just have two for loops, okay, to populate this DP table instead of this whole recursive function. So that is what, and I will do a bottom up approach. That is, I will start to fill from the bottom. So I will, instead of I1, I2, I will just prefer to have I and J, okay, and both of them are going to start from the back. So I write a loop for that. I hope you already do understand what I'm trying to do. Instead of calling this recursion, I am trying to find an iterative method which will just solve this, okay, which will populate the DP table, and they start from the back. Okay, so I just started from the back. What do I need to do at first? If you remember, at first you need to okay, so instead of -1, I fill first initialize it by 0. Why? Because I need to fill the base cases at first. So if you try to remember, if I1 equals to n1 and I2 equals to n2, you need to return 0. So now how that will look in our DP table? If you try to think it very clearly, so our DP table is something like this. Okay, so this has, let's say, n1, and this has, let's say, n2. okay, and you want to see that I1 is iterating through this and I2 is iterating through this. So as they are iterating, as you reach the last row, as you are reaching the last row, if I1 equals to N1, I mean this is I2 equals to N2, and this will be I1 equals to N1. In both of these cases, I will return 0. So all of these rows of this DP should be initialized with a 0. So instead of initially I had all the elements initialized with -1, so I've just replaced those with 0, so that these two rows are these two rows should be 0. Other rows I will fill up, right? Other rows I will definitely calculate from them and fill up, but you can easily understand that why did I do this 0, okay, because of this particular base case. Okay, so now what you need to do, as I had already told you, you just need to copy the same thing and modify. Okay, to make things easy for you, what I will do is copy the same thing and just modify them. So how exactly do you need to modify? No, just my naming is different here and nothing else. I could also have used this I1 and I2. Instead, I prefer to take dpij. So instead of I1, I will write I, all the I1. So wherever I will get an I1, I need to make it I, okay. So you can go through all these I1s, okay, and make it I. Wherever you will get an I2, make it J, because that is our iterating variable, only the name is different, right? So wherever you go and get an I2, you just replace that by J. So you do get an I and a J. And instead of this recursion, you are just doing a normal DP, right? Instead of this whole recursion, you are just doing a normal DP. So what you can do is that it's very simple. So you can just place these and just remove these recursive functions and write a DP here. So it will be very simple. DP I plus 1 J plus 1, okay, and it will be DP I plus 1 J, and it will be I J plus 1, okay. So I hope it is very clear to you. And instead of this move 1 and move 2, what you can do directly is also that you can simply return this, okay. Instead of move 1 and move 2, you can just simply write this dpij, and you can just write it in one line. Why need to write two small lines, okay. So it was, the recursive statements were big, so I was just writing in two separate lines, otherwise it might have been confusing, but now it's okay. And you see, you are not returning, this is not a recursive function, so you don't need to return it. But if you do not write this, you need to write an else statement, okay. You definitely need to write this else statement, because it will again execute every time, okay, because there is no return statement. I hope these things are very clear and intuitive to you. And instead of this recursion, again what you need to do is do dp00, okay. So instead of this recursion, you write a dp and you need to return 00. So I hope you easily understand what does the states of the DP define and stuffs like that. And you see this whole function you do not need anymore. This whole function, only this small portion of the code is what you need to answer this question. Now if you try to run and check, you will see you get the accepted thing. If you try to submit this solution, you see you get the accepted thing, and your runtime complexity is also very good at this point. It's 80% beats, right? So I hope you do understand my DP solution, and I hope I was able to make things very clear for you. Otherwise, if you have a lot of practice, definitely you can directly try to write this iterative function by analyzing these DP states. Otherwise, as a beginner, how you should approach, I hope you already understood this. And now we will go to the next question, which will be very similar, okay. So it's telling you the longest palindromic subsequence. So you are not given two strings right now, but you are given a string s, and find the longest palindromic subsequence length in s, okay. So subsequence definition also given. So you, out of all the subsequences, whichever is a palindrome out of all those palindromic subsequences, you need to find the one which is having the largest value. Now I will definitely ask you to pause this video and think this on your own, because it has a neat trick. Okay, it has a very you can tell that it has a neat trick because of which you do not need to write much code. You can just copy codes from this question. Okay, so I hope I gave you a lot of hint, and now it's time to pause the video and definitely think. Okay, so after you have thought, let's try to analyze the question. You need to find longest palindromic subsequence. Now you know that a palindrome is nothing but which reads the same from backwards and forwards. Okay, it's read the same backwards and forwards. So if you try to think, if you try to reverse this string, okay, you just reverse this string, you will get the same string. Okay, you will get the same string. So you need to find a palindromic subsequence which is the largest. Now just now you solved longest common subsequences, so can't you have two strings, let's say A, okay, and let's say whatever it is. Now let's say B, and you reverse this string, it will be reverse of A. And if you try to find the longest common subsequence between these two elements, then that is nothing but the LPS of this longest palindromic subsequence of A. Okay, the LCS of these two is nothing. So I hope you already understood why exactly I am finding the LCS, because the common subsequence among the string, normal string, and the reverse string, whichever is the common subsequence, that is the palindrome, right? Because the common element between the between an original string and a reverse string, whichever is the common element, that is nothing but the palindrome. So let's say the common subsequence was something like this. Okay, let's say you want to find a palindromic subsequence ACA. Okay, let's say this is a subsequence of this string. Then if you reverse this string, then this is also a subsequence of this string. So you get a common subsequence of these two strings, common subsequence LCS, right? So you can have a common subsequence, the same code here. So what's basically what you need to do is very simple and very easy. In fact, you write a string A, you save it as an S. Now what you can do, you can reverse. Okay, you can just reverse this string. Okay, and after you have reversed, you can initialize another string B as S. So now A and B are reverse of each other, and now you need to do nothing but to find the longest common subsequence of A and B. So I hope this will be very easy. Now I will just copy this same function and I will just call this function. I will do nothing. I will just simply call this function and I will just pass these two strings A and B, and that will be my answer. So you can just return this and check that it will be very simple. I guess it will be not difficult at all. So if you try to submit this, it's taking some amount of time to run. You see, we do get the accepted thing. If you try to submit this completely, will also get an accepted solution. So I hope you do understand what I was trying to say, right? I am just reversing the string and then performing a longest common subsequence on this LPS problem. Okay, longest palindromic subsequence. So definitely I hope this was the first video of DP on strings and you got introduced to how exactly we will extend our approach of take not take to something new over here. Okay, and yeah, the ideas mostly remain the same, but we will also develop some new ideas and we will also go to much harder problems, okay, from the next video, and they will also be asked in an interview and also on the OA also. Okay, so online assessment also. Okay, so I hope this was enough for today's video. I guess yeah, so that's all for this video. I will meet you in the next video with more interesting questions of DP on grids, which will teach you more new DP on strings. Okay, so which will teach you more new concepts and which will make your life easier for online assessments and also for your interviews. So definitely keep following this playlist. Thank you so much.